Okay, all right, why don't we get started here? So my name is Vinod Madabushi. I'm an enterprise solutions architect with AWS. I've been with AWS for about 4 years now, and I've been working with Microsoft technologies for over 15 years. So today we're going to talk about how to secure your Active Directory deployments on AWS. Your clicker doesn't work. How many of you folks are familiar with Active Directory or have hands-on experience with Active Directory? Great, perfect. So it looks like you're all in the right session. If you're not, this would be the time for you to find the right session before we get started.
Sorry, let me try. It's just fine.
Okay.
So you have to hang up the computer. I'm sorry.
Okay, yeah, I'll try that. All right, so what are we going to talk about today? So we're going to talk about Active Directory basics. Since you guys are really familiar, this will be a really quick slide on why Active Directory and also why Active Directory on AWS. We're going to talk about typical deployment patterns. And the reason we want to cover a little bit of this is we want to understand how customers are deploying in AWS so you can think about how to secure those deployments. And then lastly, we're going to cover two sections, one on Active Directory and EC2 and the other one on Managed AD. And then towards the end of the session, we'll have some Q&A time, and we can talk about if you have any questions that from whatever you've heard throughout the session. Couple of things I want to note before we get started. These slides will be posted on SlideShare in a couple of days, so you don't have to take pictures. You can if you want, but the slides will be online and available to you. The recording will also be available to you on YouTube. Again, it takes a couple of days. I have two of these sessions, so I'm not sure which one will be available, but one of the two will be available online if you guys need to refer back to it. All right, so what won't we cover in this session today? So we're not going to cover best practices on how to organize your Active Directory data. And by that, I mean, how do I structure my OUs, and how do I use what kind of groups, and how do I apply the right group policies to the right computer? So we won't go into that. Today, our focus is going to be more on security rather than Active Directory itself. To that effect, we won't go into how to design your Active Directory infrastructure. So we won't talk about what is the right way to use multi-region, what's the right way to deploy domain controllers. So we won't go into that as well. And lastly, we won't talk about the feature comparison of Managed AD versus AD on EC2. Again, that's something that's Active Directory itself and not so much into security. But what we will cover is security aspects of both of these deployments. All right, let's start with an Active Directory basics. What is Active Directory? It's basically Microsoft's implementation of an LDAP directory that has a lot more features added to it, right? And customers have been running Active Directory for 2 decades or even more, right? So it's a really mature LDAP product. What do people use it for? Well, you use it for organizing users, computers, groups, and everything else for administration in one place, right? So this is where you have your basic identity. You may have service accounts, of course, all the computers that's a part of the domain, and that's where you keep everything in one central place. Folks also use it for group policies. So this is a really powerful tool, right? You can push configurations across a large fleet of users and or computers, and you can unify communication and manage everything in one place. Lastly, most people use Active Directory to control access within the enterprise. So this might be logging into the Windows servers or logging into application itself that may be either Active Directory aware or using some sort of LDAP or LDAP-S mechanism. And even access to third-party apps, right, using SAML or Federation. For example, you could use that to control access to AWS console as one example. So why do customers deploy Active Directory on AWS, right? First thing is supporting Windows workload on AWS. So there are a lot of customers that use Windows, and they have a lot of investments in Windows. They've been using Windows for a while, also have skill sets in Windows, right? So when these customers migrate to cloud, they deploy these Windows servers either as a lift and shift mechanism, or even when they deploy new applications, they deploy on a platform that's familiar to them, and they have the knowledge of how to maintain and run. So one of the biggest reasons people deploy AD on AWS is to support these Windows workload that's running on AWS. The other reason customers deploy AD on AWS is to reduce latency. What we mean by that is, let's say you have an application running on AWS. Technically, you can attach that to an Active Directory running on premises. You could have a VPN or a direct connect and access those domain controllers, but that's not most ideal, right? Depending on where your Active Directory is and which regions you're operating in, your latency may or may not work for you. So that's one of the reasons customers deploy Active Directory on AWS to support those workloads. Also resiliency, right? What happens if you have an issue with the network? What if you have an outage with one of the network links connecting your on-premises in AWS? So then the directory becomes available, which causes application issues. So to kind of mitigate both of those, people deploy Active Directory on AWS. Lastly, to manage AWS service and resources itself. So this is where you would federate to an AWS console, where you can use the Active Directory credentials to log into AWS, or also access to AWS native Windows services, like, for example, RDS or FSX for Windows file servers, right? So when you use these kind of services, customers use Active Directory to control access to these services when they use them. All right, so what are the choices for running AD on AWS? So broadly speaking, there are two main choices. First one is you're going to run what's called as a self-managed Amazon EC2 AD. So in this example, what you do is you deploy an EC2 instance in your VPC, and then you install the ADDS tools and components on a Windows server. Then you make that into a domain controller, right? Either you make that an extension of your domain on-prem or a brand new domain. In either cases, we categorize that as running AD on EC2, where you manage everything, right? You manage the security patches, you manage the domain controllers itself, you manage the backup, so on and so forth. The second one is what we called AWS Managed Microsoft AD. So this is a service from AWS where we manage the domain controllers and the infrastructure for the Active Directory, and you are responsible for managing the data within the Active Directory. So in that example, we're managing the domain controllers, we're managing the replication, backup, snapshots, so on and so forth, and you're responsible for provisioning users, provisioning group policies, computers, and all of that data that goes within the Active Directory. Now, using these two mechanisms, there's a lot of ways to deploy Active Directory using combination of these two, right? But for security purposes today, we're going to talk about how to secure each of this, right? Or what are some of the security considerations that you should be thinking about? So irrespective of how you architect the solution using a combination of this or even one of these, you're familiar with the security aspects of it, right? Okay, so before we talk about AD security, let's look at what a typical deployment pattern looks like on AWS. Again, there are so many ways to deploy Active Directory on AWS. I mean, it's just countless, right? So we won't spend time in those architectural patterns, but we want to give you two fundamental deployment patterns that we see a lot of customers do, and we'll just focus on that so you kind of understand broadly how those two patterns work, and that absolutely helps you with how to design the security for either one of those. Okay, so first one is extending on-premises AD domain to AWS on EC2. So we talked about EC2, right? So this is where you deploy an EC2 server, install ADDS, and make it a domain controller. So the example I'm showing here, you basically have two domain controllers. On the right, you can see those boxes. So you run them in a private subnet, you launch them on EC2, and then potentially you extend your domain to that. So in the sense that you make them domain controllers for your existing domain. Of course, you have to have some sort of network connectivity to do that. So either direct connect or VPN or pretty much anything you can think of works for that. So in this case, the two domain controllers that are running on AWS are just like your on-premises domain controller. It's just located in a different site, as you will, from an AD perspective. And they will replicate between the on-premises domain controllers or any other sites you have, right? And you can see that on the red line. So the red line indicates the replication of the Active Directory itself. Now, if you have application running on AWS, they will use the domain controllers that are in AWS for authentication, group policy processing, so on and so forth. And the way Active Directory does that is by using sites and services. So it'll discover what sites and services are available, what that servers itself are a part of, and what domain controllers are available in that site. So in this model, the authentication traffic automatically goes to the domain controller that's running on AWS because it's defined as a single site, and all of them are located in that single site, right? So when a remote admin logs onto their workstation, of course, their authentication goes to the local domain controller wherever they are. But when they RDP into one of these servers to manage or administer the application, that authentication traffic will go to the domain controllers on AWS. The second way to deploy this that we see commonly is what we call a resource domain. So people deploy managed AD in what we call a resource domain. So in this example, you see the managed AD on the right. Those are the two big red boxes. So you deploy a separate domain/forest that's different from your on-premises domain. And then you set up a one or a two-way trust between that domain and the on-premises domain. And your requirements may dictate whether you want a one-way trust or a two-way trust, but one-way trust is a lot more popular, we have seen with the customer. And in this model, the apps you see, so the web servers, app servers, and all those, they are members of the domain that's on AWS, so that's a member of the managed AD. The computer objects itself are located in the managed AD. The service accounts are located in the managed AD. But the user accounts, right, this is what the account you use to administer, that's still in your corporate domain controllers. You're not replicating that, right? That's the whole purpose of the one-way trust. So you can leverage these credentials into any of these servers without replicating them. So in this model, again, thinking about a remote admin signing into one of the workstations, the remote admin itself, again, uses the local domain controller, authenticates into his PC or workstation. When they RDP to the web servers, that authentication traffic will flow back to your on-premises domain because those accounts don't exist in the AWS managed AD. Because you're using it as a resource domain, only resources that are computer objects and service accounts are located there. So one thing to be wary of in this configuration is you have to have network that's pretty redundant and robust, right? Because if your network connectivity goes down, you might run into situations where an admin may not be able to log into the workstation or the servers and do something when they want to, right? Of course, Windows has the concept of cache credentials. I know a lot of people probably use that, and some of you guys don't. So if you do have cache credential, that will help even if the domain controller is not available. But again, for most part, you want that network link to be pretty robust. So using a combination of these two, there are a lot of architecture you can build on AWS. You could have a complete disconnection between the two. You can extend the same domain. You can build a brand new domain on EC2. So your requirements is going to drive how your AD looks like, but we're going to talk about security specifically, right? Okay, so what are some of the reasons why customers choose one option over the other? Well, you're probably deploying AD to EC2. Number one, if you want to extend your existing domain or forest and don't want to build a brand new domain, right? So managed AD does not support extending your domain if you want to use that. So if you want to use managed AD, it will be a brand new domain that's different from on-premises. You could have trust, but you cannot extend your domain. So if you want your domain to be available on AWS, that would be one of the reasons you may choose to go with EC2. Or you want domain or enterprise admin privilege to be available, to you, for you to manage, right? So when we deploy managed AD, the domain/enterprise admin credentials are logged away in an automatic control and not available to you for you to use as a customer. We give you what's called as a delegated rights, which I'm going to talk about towards the end of this presentation, but you don't actually get domain or admin privilege. So if you need that for some reason and you have to have control over it, maybe you choose EC2 instead. If you want to extend your users, groups, OUs, and GPU, so you already have a structure, right? So you have an OU structure, you have a GPU structure, everything is configured, ready to go. So if you don't want to redo some of that work again, and you just want to leverage that, then maybe you might use Active Directory on EC2 because when you deploy those domain controllers, everything is replicated, everything is there. All you have to do is add workstations to the domain, and you're good to go. Lastly, single unified environment. So if you want one environment for AD, irrespective of whether the application sits on premises or AWS, you just want to see it as one unified environment, you may do AD on EC2, again, because you cannot extend your domain on managed AD. So why do people use managed AD as a resource domain? What are some of the use cases for that? Well, number one, they don't want to manage domain controllers, right? They want AWS to do the management of the domain controllers because they want to get out of the business of managing domain controllers. So that's the top reason for why people choose managed AD. The second is they want to delegate Active Directory itself to a different team so they can manage it. For example, you may have a cloud center of excellence or a cloud team that's responsible for applications AWS. But at the same time, you still want to maintain user identity, right? Because that's the core of your information security. That's what you need to protect, and those are your crown jewels. You still want to maintain control over that. So in using a resource domain model, you can keep the identities on premises, continue to manage them, while allowing another team or a cloud team to manage their AD and leverage that same credentials over that one-way trust. Delineation between on-premises and AWS environments. So there's a lot of reason why folks want to delineate. It could be security, it could be compliance. So in terms of AD, they want to see this as two separate environments. They don't want to see it as one environment. So if there's an issue with one, you're not propagating that back and forth, right? So that's one of the top reasons people choose the resource domain model and do managed AD. Lastly, native integration with some of the Amazon Windows-based services, and these are RDS, FSX, single sign-on, so on and so forth, right? So if you want native integration, you're using these services, that's another reason to do the managed AD. It doesn't mean that you can't use these services if you're doing AD on EC2. You still can. It's just not a native integration. You would have to deploy AD connectors, and there's a couple of more steps involved in leveraging this, right? Whereas with the managed AD, it's you can share the directory and you can use these services right away. How many of you are familiar with shared security model in the cloud? Okay. So that's good. So we're in the right place here, right? So before we jump into security, let's talk about shared security model. So you can see a bunch of things here, right? Where the orange is what AWS is responsible for, the blue is what customers are responsible for. But if I have to summarize this in a single line, AWS is responsible for security off the cloud, and customers are responsible for security in the cloud, right? And the delineation, the line of what we do versus what customers are responsible for might move a little bit based on what service you're running. For example, if you're running anything on EC2, we're responsible for everything till the hypervisor, and you're responsible for operating system and up, right? So if there's a security patch, you're responsible for patching those. User access control, you're responsible for making sure the credentials are strong, they're rotated frequently, so on and so forth. But depending on the service, that line moves up a little bit. For example, if you're using AWS Managed AD, we are responsible for operating system updates and patches. We're responsible for maintaining access to the operating system itself. We're also responsible for Active Directory on top of that, right? Whereas you're only responsible for managing the Active Directory data and nothing else, right? So I just gave you one example of how that line moves. But typically speaking, depending on what service you're using, that line moves a little bit, but there's still a clear delineation of what we do versus what you guys do. And it's really important to understand this, right? Because this is the fundamental of how cloud security works and how you can secure everything in the cloud, right? This, by understanding this. So I just want to bring this back. You may have seen this before, but really important to call this out. Account structure. So how many of you have heard about landing zone or control tower? Okay, there's a good number of you folks. So last reInvent, we launched a couple of new services. We announced Control Tower, and we also announced the launch of Landing Zone. So what these two services do is they give you prescriptive guidance of how to structure your account, especially in a large enterprise organization. So you can separate things that need to be in a separate account and provide role-based access control to folks who are managing them. I've just shown you a small example of this, right? So in this example, you have one master account, which is also an AWS organizations master. And then you have two accounts, one for security and one for log archive. So in this example, your security team would own control of that security account where they have their tools and services to protect all of your AWS account. And they would turn on things like guard duty where, that would be the master guard duty. And then, all other guard duties would be reporting back to this master. And they may have many other security tools, right? But they basically have that account where they run all of that. Similarly, we talk about a log archive account where all your logs from every account goes into one place, which gives security and auditors one place to look at everything going on with AWS account. So we're extending that concept a little bit to Active Directory, right? So Active Directory has to be separated from your business units, and I'll talk about why. And when you think about Active Directory, it's managed by a central team for most part. Every one of you probably have a team in your organization that's responsible for Active Directory, right? Some folks may be responsible for the data, which is user provisioning, and others may be responsible for the domain controllers, replication, and so on. But irrespective of that, you have a dedicated team that manages that. So the way to provide a reliable, robust, and secure Active Directory service to all your business units is by centralizing Active Directory in a shared service account. Again, we're not saying this is the only way to do it. This is one of the approaches we think works for most. There might be edge cases where, particularly for your use case, this may not be possible or feasible, and you may modify from this and do something slightly different. But for most folks, this model works, right? So in this model, I talk about a shared services account, but you can actually run this either as a shared services account or in an Active Directory account itself. Both of them are an option. Depending on how many things you have running in shared services and who has access to them, you may choose to go one way or another. But the high-level takeaway from this is don't put domain controllers along with business units or somewhere else. Co-locate it, centralize it, so it's easier for you to protect it, make it highly available, and so the business units can use them. All right, so let's talk about EC2 first. So if you were running Active Directory on EC2 and doing this on your own, what are some of the things that you would need to look out for? Okay, first thing is account security, right? We talked about how to put Active Directory in a single account. So what you want to do is place all the domain controllers in a single account. So whether you're using multi-regional deployment or single regional deployment, consider deploying VPCs in that same account that will host domain controllers, and you centralize all the domain controllers in that single account. Again, we'll talk about why and why it's useful to secure it, but the high-level idea is that. We talked about shared services account. So shared services by nature means there are common services that all your business units needs, and you're providing that, right? So which also means there are multiple teams operating within that single account. So if that's the case, and you're putting Active Directory in a single account, make sure to use tag-based policies to restrict access. And the reason is you want to make sure folks who have access to EC2 and or EBS only have those access because they're doing something in the Active Directory, right? So by enforcing the tag-based access and putting the right tags in for the domain controllers, you'd be able to ensure that those folks only have access and other people who are operating the account can't do anything with the AD. Okay, so when you're running on EC2, these two things are really, really important, right? EC2s are your domain controllers, those domain controllers, right? So make sure you limit access to who can start, stop, and terminate, and also who has access to the EBS volumes that's attached to the EC2 instance. Again, two separate impact, right? From the start, stop, terminate, you don't want folks to kill a domain controller or stop causing an outage, those who don't have access, right? So this should really be, both of these functions should really be limited to Active Directory administrators who should only have this access. In terms of EBS, you don't want folks to take a snapshot of your Active Directory or attach that EBS volume into another instance and copy your database file. That would be pretty bad, right? And the way you restrict that access, again, is by tags and by restricting access to who can do that. If this was in a separate AD account, this would be a lot more simpler because you would then hand over the entire account's control to the Active Directory team rather than try to use role-based access control based on tags. But either model works. It's just what's simpler for you and what's better for you, right? Lastly, follow the best practices for managing the root credentials. As you guys may be already aware, a root account can override any of the policies that you put in place. So make sure that you have MFA turned on, the root's secured away. You're not using it on a day-to-day basis. It's only for the handful of things that really need it. And lastly, it should only be with people who potentially may have Active Directory access and or responsible for security of it, right? Because you don't want, say, a business unit access to a root credential, which then gives them access to Active Directory, which otherwise they would not have, right? So you want to really separate that. Network security. Well, we can't talk about security without talking about network, right? So before we jump into network security, let's talk a little bit about that architecture over there. So we talked about centralizing domain controllers in a single account. So essentially, I have a private subnet multiple availability zones. I have a couple of domain controllers. Now, this is all regional. So if you are operating in more than one AWS region, you would have a replica of this pretty much in every region, right? We don't want to cross regional boundaries, right? Because Active Directory needs to be in that same region based on the services it provides in terms of latency and best performance for your apps. So domain controllers are located in a private zone, and you have a number of VPCs. These are VPCs that belongs to your business unit. This is where they are running applications, right? This could be any of their business applications, and they're not actually located in the same account because we talked about keeping Active Directory in a separate account. So essentially, the VPCs are all located in different accounts, but you can still connect them to the shared services or AD VPC using VPC peering, TGW, or pretty much any network technologies you'd like to use, right? Just make sure it's highly available, right? So this is typically how we see Active Directory deployed in a single region, and every region will repeat the same logic. So in this example, let's talk about how the security groups works for the AD. Well, the first thing we want to do is allow AD ports from all these VPCs that have domain members, right? Security groups have a limitation on the number of rules you can add, so we don't want to get down to writing rules based on individual members or hosts. We want to write them based on subnets where you have hosts that require AD services. So if you have 3 VPCs and one of them have no reason to talk to AD, you would not have that one VPC in the security group to allow, right? You would just completely ignore that VPC. So you would only allow VPCs, and you can get down to subnet granularity if you like, but for most part, we have seen that this simplifies design, and it simplifies the access controls that you guys need. Lastly, the domain controllers itself will talk to each other, right? So those ports are open between the two, so we typically see that being fully available to talk to each other. And of course, if you have an on-prem domain controller, and if it's either a replication or a trust, then you want to make sure that to be very granular about this, right? So you're only allowing on-premises DCs, only on the AD ports or trust ports to talk to these DCs. So you want to be granular on the security controls. Okay, how many of you have seen this table? I'm sure it's everybody, right? Okay, so Active Directory uses a lot of ports, and I mean, for good reason, right? Provides a lot of services. So you can see it does LDAP, LDAP-S, DNS, and so on and so forth. So this is pretty popular if you guys have dealt with Active Directory. This is also one of the reasons most people say, well, I'm just going to open everything just because this is a lot of ports, but we recommend not to, right? There's a couple of reasons for that. But I want to focus on a couple of things here. One is this, DNS. So for most people, domain controllers are also their DNS servers. They'll use them as DNS because they support integrated zones, it's secure, and they like to use them, which is great. Some people don't use them, right? Because they may have appliances, they may have other DNS servers because they don't want to combine the two functions. So depending on whether you do or don't, you don't need to allow TCP or UDP 53 if you're not using it for DNS function, right? So think about that when you configure this AD ports, because this is just another thing that you just don't have to have open, and it just reduces the scope and impact of attack surface, right? Lastly, the ephemeral ports. So these are ports that are used by Windows RPC service. These are ephemeral ports, and these are a large number of ports. It's just the way the RPC works, right? So typically, we leave all these ports open because the Windows server will initiate a connection back. Now, the thing I want to focus on here is the range of the ports. So if you started with Active Directory 2 decades ago, this was all the ports, right? From 1024 to 65535. Microsoft has gotten better in reducing this number of ports on newer Windows servers, right, running Active Directory. I believe 2008 R2 and higher, you don't need to open everything from 1024. You just need to open from 49,152, right? So that kind of limits 48,000 ports that you just don't have open, right? So if you're running newer domain controllers, go back and check your security groups to see if you still need everything, or narrow them down to this new port range instead of just leaving everything open. Lastly, I want to call out a URL, Microsoft URL, that you can go visit later. So this talks about how to restrict RPC traffic coming to an Active Directory to a single port. Again, it's not all of this to a single port. It's just talking about the ephemeral ports, right? You still need all other ports for other services. But if you want to limit, if you don't like these large ranges, you could limit it to a single port, and you can go read up on their documentation on how to and what are some of the implications of doing that. Okay, let's talk about other network security considerations. So NACLs. So we have a lot of tools, security tools available on AWS for you to use. NACLs is one of them. When it comes to Active Directory and how many ports we have and how it works, it can be tricky to implement them and implement them correctly and have it be really effective. So we're not telling you not to use it. We're telling you to use it if it's necessary and you can't control traffic and using any other mechanisms like security groups and routing and so on, right? Just because of the complicated way of doing it, stay away from it, but if you have to use it, you should use it, right? At the end of the day, you should only restrict what you want to allow. This may sound obvious, still want to call it out. Don't put domain controllers in public subnet. There's absolutely no reason for a domain controller to be in a public subnet. It should always be in a private subnet. I know there are some of the folks that's thinking, well, I have my domain controllers doing internet name resolution. How is that going to work if it's not in public subnet? And I'm going to talk about that as well. Multiple AZs. Again, this is more of an availability thing rather than security, but always deploy domain controllers in multiple AZ. Don't ever deploy them in a single AZ, because if you may have an issue with availability if there's an issue with that AZ, right? Routing table, right? Nobody thinks of routing table as a security mechanism, but it really is, right? So routing tells you, routing table allows you to configure what networks you want to talk to the VPC that hosts the Active Directory domain controllers. So for example, if you have a direct connect or VPN back to your on-premises, and you may have a lot of 10 dot subnets in your data centers. So instead of routing everything to that VPC, you can only route subnets or list of subnets that have your on-premises domain controller, right? So essentially what you're doing is you're limiting the amount of traffic that can even come into the VPC before employing other mechanisms like security groups and NACLs and so on. So if you ever configure a VPC or Direct Connect, think about whether everything should be routed or if you will pick a subset of networks that should be routed to the VPC that has 80. All right, so I promised to get to the internet name resolution from the DCs. So again, going back to the setup we had before, we had a couple of VPCs. We have some domain controllers that are in the private subnet. Now, how do I resolve internet name, right? So in the case where you're using DCs for DNS, every query from your member servers on AWS in a single region is going to come to these DCs. So DCs will automatically resolve DNS that's authoritative to the zones it's hosting. But what about those internet names, right? So we have a couple of choices on how we can make this work. First thing is, send them to the Route 53.2 resolver, right? So the .2 resolver is the resolver we offer you in every VPC that you deploy something. So instead of using the root hints for external name resolution, send everything to the .2, so you'll unconditionally forward anything that it's not authoritative to .2, and we'll take care of resolving that for you. This also has another added benefit. If you're hosting Route 53 private zones, we can resolve them too. So any traffic that's coming into the VPC into that .2 will resolve all of the private hosted zone associated with that VPC, right? In addition to internet names. The only thing you have to remember here is there is a 1024 packet per second limit when you hit the .2 resolver from a single host. You may have seen it, you may not have come across it. It sounds like it's not a lot, but it is a lot in terms of DNS because these resolvers, the on-domain controllers, cache a lot of stuff. So the number of queries that actually go out is a lot less than you think it is, right? But if for some reason you do hit that limit, then you would have to architect this slightly differently instead of relying on .2. But otherwise, this is a great way to not expose domain controllers to internet when you have to resolve those names. The second option is to use DNS servers in a public subnet. So again, the idea is keeping the domain controllers away from internet access, both inbound and outbound. So what I can do is instead of sending it to .2, you can run your pair of resolvers. If you're already running them for whatever reason, maybe authoritative zone or whatnot, we can send the traffic to those DNS servers, which are in a public subnet, which will then resolve the internet query and send the results back to the DC, right? This is another option for you. Lastly, you can have a NAT gateway and have the DCs go out to the internet using the NAT gateways. So this is outbound only access, right? NAT gateway is a unidirectional service, so no queries, no unsolicited connections can come from internet to your DCs, but you can initiate outbound connections to the internet through the NAT gateway, right? So out of the three options we have, this is probably the least preferred, again, because you're exposing the DCs to outbound root servers or other DNS servers directly. So if there was a DNS vulnerability and your DCs weren't patched for it, you could potentially be affected by it. Whereas having .2 or another DNS server in the middle shields you from a lot of that, right? All right, so let's talk about encryption, right? LDAPS. So most people are probably familiar with LDAPS, and it's the secure version of LDAP, and a lot of apps will support it. So if your app support it, use LDAPS, so you're not sending clear text data over the VPC or even over the direct connect in the text, right, in the clear. Encrypt EBS volumes. So this is encrypting data at rest. How many of you folks are familiar with KMS? Okay, most, that's great. So KMS is our key management service, which is natively integrated with a lot of AWS services, which allows you to save your keys so you can encrypt both, in AWS services, in EBS, you can encrypt the data at rest, right? So use KMS and attach or encrypt the EBS volume that's attached to the domain controllers. Encrypt both the C drive and the D drive. I know some people separate the data versus the C, but there's no reason not to. If you're operating in a shared account, use a separate CMK, or we call customer master key, for Active Directory. Again, CMK, you can create a number of CMKs, and you can define who has access to what CMKs. By creating a separate CMK and restricting access to only Active Directory administrators, you're narrowing down the scope of who can use that KMS key and access that EBS volume, right? So even if somebody gets access to an EBS volume, without KMS, they cannot see any encrypted data. So it's kind of layered security where you want to do both, not one or the other. Lastly, Cloud HSM. How many of you folks know what HSM is? Cloud HSM. Some of you. Okay. So Cloud HSM is a hardware security module where we store the keys in a separate hardware security module dedicated to you, right? And you can use HSMs if your security mandates for it or compliance mandate for it on how your key should be stored and maintained on AWS. I'm going to talk about that in just a minute here. So this is kind of our KMS service. So you have the KMS service, and then you have what we call the HSM fleet. So KMS is a shared service, so all the customers' keys are still managed in a hardware security module, but it's combined and co-located into a fleet that we manage. If you prefer to manage your own keys in your own cluster, you can create what called as a Cloud HSM cluster. You can keep the keys there, and then connect that to the KMS using what we call custom key store. So what this allows you to do is encrypt the EBS volumes, use KMS to encrypt the EBS volumes because it's seamless and EBS supports KMS, but store the keys in your own cluster instead of the shared fleet that we have. So if you have security requirements, compliance requirement that requires you to manage your own keys, this is how you can leverage the two services to encrypt your data in domain controllers. Okay, so logging and monitoring. So security logs have wealth of information about your domain controllers. You guys probably know this. You're doing a lot of security logging today in your data centers. So extend that when you run things on AWS, right? These are your best source of information, so make sure to monitor them, make sure to collect them, centralize them, and also alert on it, right? VPC flow logs. So VPC flow logs gives you information about headers of packet that goes in and out of VPC, or even in and out of subnets within the VPC. So make sure you turn them on and save them somewhere. It helps you with troubleshooting. So when you have a communication failure, instead of just opening the security groups and seeing if things work, you can actually look at the flow logs to see if anything was dropped. So that would conclusively tell you if it's a security group issue or an ACL issue or something else, right? So turn it on and use them for troubleshooting purposes and also security. If there's an incident and you want to find out what happened in terms of network communication, you can go back to the flow logs and do a bunch of queries and figure out exactly what happened. Make sure to set up real-time alerting. This is more important than just monitoring, because when there are key events, you want to know right away, right? For example, CloudTrail. So make sure to turn on CloudTrail. So when people stop a domain controller or create a domain controller, you will know exactly who did what, when, and you can go back to the CloudTrail. Also, turn on key events in the CloudTrail for monitoring, right? For example, if you have an Active Directory account and somebody logs in with the root credentials, you should know about it right away, right? Those are the proactive type of monitoring you definitely want on. Monitor the DCs for availability. Again, set up EC2 auto recovery. So if there's a hardware failure and the domain controllers stopped, you want to turn them on automatically so you don't cause availability issue. So make sure you set that up. Again, this is something you're probably familiar with, but restrict who has access to log into domain controllers. This shouldn't be an everyday function. Most of the time, this isn't required except for things like security patches, updates. So this is more of a once a month thing. Even that, if you have automation, you don't actually need to log into the domain controllers. Perform administrative tasks from a management server. So don't log into the DCs to do things like create users or managing group policies or so on. Make sure that you do it off of an administrative computer or domain member that's not the DC. Lastly, backup your AD environment. Make sure the backup is secure. So this means encrypting the backups, not just the drives, right? So because when you use third-party backup software or even snapshots are encrypted when volume is encrypted. But if you use third-party software, it may or may not encrypt it. So wherever you decide to store them, either in S3 or another EBS volume, you want to make sure that location is encrypted as well. All right, so let's jump to AWS Managed AD Security. So how does AWS do security for Managed AD? What are some of the things that you should know when you're running Managed AD, right? So first thing, AWS Managed AD is single tenant. So this is one of the services where we don't co-locate user data. So when you launch a directory on AWS Managed AD and we deploy domain controllers for you, these are single tenanted, only your data is on it, only you use that. If another customer launches another Managed AD, we have separate EC2 instances that service them. So the data is never co-located or together. So the AWS Managed AD is also based on actual Windows Active Directory deployment. So this is not a AWS product. It's rather deployment and management of Microsoft Active Directory. We use automation. You may have heard this multiple times or may hear this multiple times throughout the conference, but we use automation quite heavily. So we don't have to have humans touch and do things. This might be deploying your environment. This might be resolving issues with your environment, backup, snapshots, whatever it be. We try and automate most of the things. And when we do have human touch something, there's an elaborate process to make sure that they get a temporary access based on the credentials, and it's time bound, and there is a ticket that does require them to log in and do something, right? So we follow all of those processes whenever humans has to touch anything in your managed AD environment. Again, AWS employees don't have access to your domain admin credential in your managed AD environment. Those are under automated control. So when we spin up your managed AD automatically, we take those credentials, the domain admin credentials for your directory, and we automatically save them in an automated fashion in a vault, right? And we don't have access to them. And again, it's in a case that we do require that, it's a time-bound control where we get access for this person working on this ticket for this much period of time, and that's about it. We deliver all the security logs from domain controllers to CloudWatch. So again, security logs have wealth of information. We want to make sure that you guys can use that information, monitor it, and alert on it real time. So we automatically push all of these logs to the CloudWatch. So you can consume it from CloudWatch directly in any fashion. If you have tools like third-party tools like Splunk or whatnot, you can directly pump the CloudWatch into Splunk to help you with analyzing that information faster and alerting on it real time and making decisions right away. Delegated admin access using predefined groups. So I mentioned this earlier in the presentation. So when you launch an AWS Managed AD, we don't give you domain admin credentials. We give you what's called as a delegated credential. So those are credentials that give you administrative functions to do everything you do within the directory. Create OUs, create users, create groups, assign group policies, do all of those things, but without the domain admin credentials. And that's what allows us to run the service securely, reliably, and in a highly available fashion. So that's how you get control over it. So when you launch a directory, that's what you get. And then once you get that administrative credentials, you can then use management server to go provision everything else within the directory. So that's the one account we will give you when you launch a directory. Account security. So the same thing we talked about in terms of account still applies to managed AD. You still want to locate it in a single account, and you still want to restrict access to the directory service. This is a little bit more easier than doing the tag-based EC2, because what you can do is write IAM rules or policies to give somebody access to the entire directory service in that account, and you're done, right? It gives them access to spinning up directories, terminating directories, so on and so forth, without really going to the granular level of only talking about or giving access to the EC2 instance. Lastly, same best practice in terms of root credential. It's no different whether you use managed AD or EC2. In terms of network security, we do two things. One is, when you launch a managed AD, we automatically apply a security group for you that only allows AD ports. And by default, only the domain controllers are talking to each other. So before you can even use the directory, you have to add VPCs and or subnet CIDR ranges into that security group before AD is even available, right? We also don't allow you to log in or RDP into the domain controllers. So when you launch domain controllers, you'll get 2 ENIs or IP addresses. So those are your domain controllers. But when you try to RDP to them, that will fail. But it will accept all the AD ports, and it'll function just like a domain controller. So the way you manage your AWS managed AD is via the management server. And you can still use the Microsoft native tools like ADUC and GPMC and all that. But you would use the server rather than logging into the DCs to do it. DNS name resolution. So again, we talked about how you can get that DNS name resolution to work. If you're using the AWS managed AD as DNS servers, we automatically do the forwarding for you on the .2. So internet names are automatically resolved, and we manage that for you. We also encrypt all EBS volumes by default. So there's none of your data, Active Directory data or otherwise, sitting in clear in any of the disks. And we use KMS for that. We also encrypt snapshots, and those are also stored securely. Lastly, LDAP-S. So by default, when you launch AWS Managed AD, LDAP-S is not turned on by default because LDAP-S requires a certificate service, right? So, but it is supported. What you need to do is first set up a ADCS or certificate services, and then set up managed AD to go pull certificates from there before you can turn LDAP-S. So it's supported, but it's one extra steps before you get there. Shared responsibility. So this is a big table. So we'll talk about summaries, right? We talked about shared responsibility, but we're going to look at how that applies to AWS Managed AD. So on the left, we are responsible for a lot of things we talked about. Protecting the hardware, software, so we run on EC2, so we protect all the stacks underneath. We also isolate you from other customers, manage your domain admin credentials, apply security patches and updates when Microsoft releases them on a monthly basis, maintain the availability of the directory. So the way we do that is by deploying in multi-AZ by default. So if one AZ wasn't available, the other one always is. Even when applying patches, we apply in a rolling fashion, so we never apply patches to 2 DCs at once, right? We also manage and monitor application. So if there's an issue with the application, we are responsible for fixing that. Lastly, we do a daily snapshots, automated snapshots. So if you ever want to restore your directory back to the previous day, you can do that, but we're doing that for you, right? The snapshotting itself. You're responsible for managing the data itself, OUs, groups, group policies. If you have trusts, you will be responsible for configuring them. Again, you're responsible for making sure the AD is available over the network to wherever your applications are. We do allow schema updates, but you're responsible for providing the compatible LDAP file for a schema update. Lastly, LDAP and MFA, you're responsible for turning those on before you use. Okay, compliance. I know a lot of application needs compliance, right? So you have a whole bunch of compliance requirement, and you're probably wondering, can I use AWS Managed AD if my application needs to meet these compliance requirements? Absolutely. Managed AD has a lot of certification, and this is just a subset of them, right? I want to talk about 3 key things that we get asked over and over again. Those are the HIPAA, the PCI, and the FedRAMP. So if you have applications that need to be PCI compliant, HIPAA compliant, or FedRAMP compliant, we have Managed AD that can support you in all of these 3 use cases. So again, you'll deploy Managed AD. Managed AD already has the certifications and our required compliance. You would then, you would then work on the rest of your application stack to make sure it's PCI compliance, right? So yeah, absolutely, you can still do that. All right, so if you have any questions, I'm going to be right here, so feel free to stop by if you have any questions. Thanks a lot for attending this session. I hope you found this really useful. Please make sure to complete the survey in the mobile app. This is how we gather feedback from you and improve our sessions to better suit your needs. So please provide feedback, and that'll be very helpful. Thanks a lot.